Hello, welcome everyone, and today we will cover one chapter from physics, grade 10 physics. That chapter is chapter number 11, human eye and colorful world. As we know that human eye portion is eliminated from the syllabus from the board exam for this year, not from whole life, not for whole life, but already we have covered in class. But now here in these video lectures I will not take that topic. We will start from colorful world, the second half of the chapter, and the very first topic for today is refraction of light through a glass slab. We know that when light passes from one medium to another medium, the direction of light changes. That is known as refraction of light. So how does the light ray bend when it passes through a rectangular glass slab? We will cover that topic. The very first topic for today is, so let's begin without wasting time. As you can check here, in this diagram, refraction of light through a rectangular glass slab. This is one rectangular glass slab. We will draw this diagram on the next page very properly. I will tell you the steps how to draw. But what we are checking actually, if one light ray passes from here, it must go straight. It must go straight if this glass slab is not introduced. But we know as glass slab is introduced here, so this light ray bends like this, in this direction. It bends. When it comes out of the glass slab, again medium will change, so definitely it will change the direction. So our target is to trace the path of light ray when it passes through a rectangular glass slab. On next page we will try to get this type of path of light ray. Let's see. Yes, now this is rectangular glass slab. Now I am taking one light ray which enters from this side. Okay, one light ray which enters from this side, and this I will call incident ray. In short I am writing this is incident ray. Alright, this is point of incidence, so I will draw normal here, an imaginary line perpendicular to the surface. This is normal, giving a name, okay, normal 1, N1. Now light has a tendency to travel in a straight line, so this must be the straight direction of light ray, but as it passes through this glass slab, definitely it will bend. How does bending take place? This light ray will bend away from the normal or towards the normal. We will decide according to medium. Outside it is air, and this is glass, right? It means light ray is passing from rarer to denser medium. Air to glass means rarer to denser medium. So light ray will bend in this manner towards the normal. This is normal here, so light ray will bend towards the normal. Okay, fine. Now again light ray will change the medium here, so we will take another normal from this point, from the point of incidence here, and again now light ray will bend, but this time this is passing from glass to air, means denser to rarer medium, so it will bend away from the normal. And now this time we will be very careful that this light ray after bending, it becomes parallel to the direction of incident ray. It becomes parallel to the direction of incident ray. Why? Because incident ray and this light ray which is emerging out, this we call emergent ray. This is emergent ray. These are in same medium, so direction of these two is parallel. You can check, these are parallel. Where is angle of incidence here? Here in this case, this is angle of incidence I. This is angle of refraction R. Reason? Because this is this light ray. This light ray is refracted ray. I am writing RR, refracted ray. So angle between normal and refracted ray. This is angle of refraction. This angle, this is angle of emergence. Here E, angle of emergence. Angle between normal and the emergent ray, angle of emergence, right? Here, this distance, the distance between direction of incident ray and the direction of emergent ray, this distance is known as lateral displacement. What is this D here? This D is lateral displacement. Lateral displacement means it is a shift. When light ray passes through this glass slab, the direction of light ray changes, so it is shifted this side little bit. If it will go straight, it will go here, but due to refraction of light, it is shifted this side. So this shift, the distance between direction of incident ray and direction of emergent ray, is known as lateral displacement. In this case, this angle I and angle E, angle of incidence and angle of emergence, these are in same medium, so these are equal. Relation between angles, angle I is equal to angle E. But you can check, I is greater than R is smaller, so both of these are greater than angle R. This is the relation between these two angles. This you remember beta, this is very important. In board exam sometimes in 1 mark question it comes. What is the relation between angle of incidence, angle of refraction and angle of emergence while we are tracing the path of light ray passing through a rectangular glass slab. Now you can match this diagram with the previous one. It is same or not? Light ray coming, this is the straight direction, after bending this is the path, and you check this now. A straight direction and after bending this is the path. So after completion of the ray diagram it looks very complicated, but if we know the steps we can draw any number of time. Yes, you can draw. If someone is asking you trace the path of light ray, yes, you can trace the path of light ray in this manner. And what is the role of this table that I have taken here? In this table you can see angle I, angle of incidence, angle R, angle of refraction and angle E, angle of emergence. These are few readings, few values that if we are taking angle of incidence as 30 degree, what would be the angle of refraction in that case for the glass slab that we are using in our lab? For that it will come 19 degree it must come, but it can come 20 degree also, 1 degree we can manage, okay. Angle of emergence must be equal to angle of incidence, so 30, it may be 31, 29, 30 approximate equal. Same, if we increase the angle of incidence 40 degree we have taken, so what would be angle of refraction in that case? It will come 25 degree. Yes, for 40 degree angle of incidence, angle of refraction will come 25 degree and angle of emergence must come equal. If we are taking 50 degree, then angle of refraction is 31 degree. If we take 60 degree, then it comes 35 degree, around 35 degree it comes. So this is the true table for the experiment if we are taking, because angle of incidence you will keep in one range from 30 degree to 60 degree only. Angle of incidence you cannot take less than 30 degree or more than 60 degree, no. So these are few values, few readings. We should remember these also, that approximate value. What is the angle of refraction when angle of incidence is 30 degree, so it is 19 degree or 20 degree, 1 degree difference we can consider, because we are human beings, we make mistakes, there are many errors in calculation or during the experiment also, right? So this was the role of this table. I hope now this role is also clear to you. This you remember, lateral displacement also remember. I hope this topic was very easy, right? So in next lecture we will cover refraction of light through a triangular glass prism. It was rectangular glass slab, but in next lecture we will cover triangular glass prism. Till then, you take care of yourself, right? Bye bye.